Sure. Can you take the derivative of that with respect to t? So now you have to differentiate with respect to t, time. Okay, what's the derivative of x squared with respect to time?
Isn't it 5 feet per second?
No. Well, I mean, there is the dx dt is that value, but first you have to create the equation that contains all of those. Okay, so what's the derivative of x squared with respect to time? And it's not just dx dt. It's not just the 5. What else is in there? 2x dx dt, right? So that x squared is changing as 2x times dx dt. Okay, plus, keep going. 2y what? dy dt. So there's how y is changing with respect to time. And what's the derivative for 13 squared? 0. Equals 0. Okay? Now here, I have a tendency to disagree with the way your book says to do this. In that strategy, they'll tell you to differentiate your equation, okay, and then solve for what you want. I honestly, when I look at this, I'm just going to plug stuff in and move it around after that, okay? So we have to look at this, and where's the one that we want based off of how we set it up over there? We want this one, okay? Which means that because we only are working with one equation, we have to know every other variable. So you have to have y, dx dt, and x. Do we have all of those? We have x, we have dx dt, we don't have y, but can we find it? How do we find it? Absolutely, back over here, so now we're actually talking about a specific moment in time. We're talking about when x is 12, okay? So back over here, I have a direct relationship between x and y. And I know specifically that when x is 12, I want to know about the y, okay? So now I can use the original equation and be able to find out what y is to get dy dt. So from here, we have to go back and use 12 squared plus y squared is 13 squared, okay? We need this to find y. So can we solve this for y? Sure. What is it? Y squared is 25. So y is plus or minus 5. Which one is it?
So I'll go with the positive.
It would be the positive one, right? Okay, why is it positive? It's the distance up from the top of the house. Okay, so it's still 5 feet above. Okay, so we want the positive one. So now we officially have y. If I have those 3 values, can I find my dy dt? What is it? 2 times 12 times 5 plus 2 times what? 5 times dy dt is 0. What's the only variable in there? My dy dt. Is that what I was looking for? You bet. So now all I have to do is just essentially solve this. So this is 120 plus 10 dy dt is 0. So 10 dy dt is negative 120. What does that make dy dt? Negative 12 feet per second. Why is it negative? Did we screw up? It's falling. Absolutely. Okay, so you have to think about what these negatives and positives really mean. Okay, so the fact that that's negative tells you that it's actually headed towards the ground. Okay, so it's falling, it's decreasing, you could say, at 12 feet per second, or 12 feet per second. Okay, is the rate at which that thing is. How fast is the top of the ladder sliding down the wall at that moment? So it's sliding down the wall at 12 feet per second, so the down implies that negative on there. Okay, so it should have been negative. Okay? Now, part B. At what rate is the area of the triangle formed by the ladder, wall, and ground changing at that moment? So part B, same picture.